Awesome. All right. So my name is Brian Nuskowski. I'm from Ann Arbor, Michigan. I work for a company called Duo Security. We make two-factor authentication for the world. If you haven't heard of us, or if you have RSA right now, come check it out. I went to the other CMU, Central Michigan University, not Carnegie Mellon. I could say I went to CMU, and you'd think, damn, he's a pretty cool dude. My Twitter handle here, I put the Pittsburgh flag to try to localize my presentation. I hope that's the right one. I took it from Wikipedia this morning. So this is kind of a journey of a series of unfortunate or fortunate events, depending on how you want to look at it. I didn't want to put the word load testing in the actual presentation title because it's kind of about that, but I feel like the word's too vague. So you could be here because this is a fortunate event for you because you have yet to have any type of mass scaling problems, or you don't have a good strategy in place, or it's an unfortunate event. You've arrived here because you've experienced a problem handling large amounts of traffic on your site. So you're either about to go big, you went big and you busted, like we did. That's why this talk was born. So you may have some confusions. So in the talking heads realm of things, you may ask yourself, how did I get here? How do I really load test? Is the term load testing too vague? Are strategies universal? So if I develop a load testing strategy, can I go ahead and apply it over here and here and here? Who is responsible for doing the load testing? Is it QA, is it ops, is it infrastructure, or is it the load testing team, if such a thing exists at a giant corporation? Before I get started, I want to give some shout out to some of my crew. I worked on this with these three guys, Lance, Seth, and Frank. That's where they work right now. So I just want to give them some quick credits and screen time. Two of them are in the audience, so you can embarrass them later. So the setup of the whole journey is we were a successful e-commerce company. Successful, I put an asterisk next to it because it was a relatively core part of the business. If it went down, revenue was lost. So I would use that as like a relatively loose gauge for successful. You can have an enterprise that has an e-commerce presence, but not necessarily doesn't impact the business. So we were a successful e-commerce company. Our traffic was relatively predictable and repeatable. So the company this was at, it was a logistics company that delivers food. That's all I'm going to say. So we follow what I coined as the false preparedness model, which I'll touch on in the next slide. We had really no consistent outages due to traffic-related incidents. We had no load testing definition. We also had no load testing strategy, so the kind of things just worked. So this is kind of the false preparedness model you can see we started with. So originally, like, oh, my system's going to be stable. I'm going to build 2 instances. Well, 2 is cool. What about 4? What about 10 and 20? So that's kind of like the methodology used at that point. 10 sounds like a great number for a number of Apache instances. 20 sounds like a great number. So we kind of call that the false preparedness model. Anything that's evenly divisible by 2 sounds like a good number. So we can have that many machines in the stack. So that's kind of what we followed. It wasn't really data driven. It's like, man, we have 10 and we're going to receive more traffic, so let's have 20 boxes now with no real logic behind it. So the business came to us and they wanted to experiment with a high value, like high volume promotion. They said this could generate potentially a lot of revenue and a lot of traffic. Well, traffic would generate the revenue and so forth. So we took our first swag at like figuring out what the hell load testing was. We wanted big numbers. We didn't know what those were. We kind of outsourced the logic. And we kind of relied on vendor guidance to, what are we supposed to be doing here? We'd really reach out and say, what's the best strategy? And they kind of give us magic number equals number of users who you think you're going to receive times some large variable, so you can apply a lot of scale to the site. Okay, we formed a few assumptions about our customers. The people who are on the site wanted to be there. I'll kind of explain that later. And we thought the users do what the ideal user does. They come, they perform a very a detailed task, and they leave. We thought that we could just use generic data and scenarios that would be acceptable, and we used X per interval as a success metric. So we're like an e-commerce company. I guess it was a transaction per second, like an order per second, you could say. That's kind of the metric we used. We didn't care about anything else. It was like, man, how many orders per second? That was the primary focus. So we wanted to go fast. So you can go fast 2 ways. You can here's a Honda CBR 9000 or 919. This goes pretty fast. So does the new 2014 M3. So which one do we want to ride fast in? So we chose the former. We chose the 919. So there's 2 stories with that. If you drive a 919 up to 130 miles an hour, it's relatively, you can't really control it as much as you could as M3. It's not really recoverable. They both go very fast and both perform different. So we wanted to perform our load test initially, like just right out of the gate, super fast, not really worrying about what's going to happen if we hit a piece of gravel or a stick or a June bug. So we chose the 919, we didn't choose the M3. So kind of give you an idea of what the business was like. Here's like a generic traffic curve. These numbers might mean something and they might not. So this was real user traffic on a typical day. Okay, the business opened, gained momentum, the business closed, business as usual. So we decided to go with this vendor guided test. We performed it. And here's the result of the test. So that was the test data. We relatively simulated the spin up of traffic. We got this huge peak, and we had a valley. So you can infer a few things from this graph. One is, oh my God, look at that spread. That's a huge spread. Like, look how high we hit. That's so awesome. You can also infer other things from this graph, like that was also severely degraded, and there's a lack of functionality occurring after that spike. So I don't care how high we got. There was still a problem. But some people came in the room and they asked us, what was the number? What did you hit? What's that magic number? We said, oh, well, a little over 3,000. Oh, man. So we kind of got lost in that. And, we got, oh, yeah, that is a big number. Oh, yeah. We got this. We're good to go. Load test is off, man. It was a success. We're good. So, and we had went and drank some Iron City beer. So that's the end of the story. No. Unfortunately, we introduced the high value, high volume promotion, and this happened. Well, 1,800 is not the same as 3,000. So things happened. Meetings happened. Throughout the course of the meetings, we kind of coined this program. We stepped back. We looked at all what things could be identified as critical to make this test a success. So we came up with called the 5-step program. There could be 6 or 10 if you want to add to them as well. But the first step was getting to know your users, which we obviously had no clue what they were doing. Second was getting to know your systems. Everyone has some type of visibility into how their systems operate. We thought we did, but we did not. Testing outside of the bubble. Well, these points will all be elaborated on further down the line. We need to establish larger test coverage. A small but simple one was enlist all beneficiaries and stakeholders. We didn't do that. So the first bullet point was know our users. And what we did for that, we started to identify access patterns, like in the Apache logs or Nginx logs or whatever. So we used it to create histograms and correlated events. We sampled what actual user data was coming to the site. We had a JavaScript front end, and we had a series of 20 API endpoints that people would call through their browser. So we use those as kind of the building block for measure how many times each endpoint is accessed per minute. So we correlated that, made histograms. We also enlisted an analytics team to get front end click events. So we actually get insight into what the users were actually doing. Using analytics, we identified popular scenarios, which we'll now call our workload. So in our case, we had about 12 top scenarios that created only 40% of the traffic initially. So we just picked the top 10, but it only generated 40% of traffic. So if you have 35 scenarios that generate 90% of your traffic, you need to get to that number. You can't just say, well, pick the top 10 things users do and we'll test on that. Pick as many scenarios to get to the realistic load numbers you can. So through this, we discovered that customer behavior is extremely erratic. They don't perform like that simple arrive, click, order this product, leave flow, we thought. A large percent of our customers weren't customers. They would visit the site, consume resources, almost order then leave, so that they would never convert over. So they're stealing resources from our customers who are attempting to purchase product. We didn't consider that. We needed realistic data sets using Joan Smith on 1234 Clickitat Street. Didn't really cut it for a million users trying to order. Again, used user versus system-driven behavior. We looked more to the user to give more realistic data for load testing. And we shifted from the X per metric interval to functionality per workload. Before it was like, well, how many transactions per second can we process? That was kind of too small of a viewpoint. So we switched to functionality per workload. How many of these top 35 functions can we handle per workload? So this is kind of the generic stack, 3-tier web app, persistent data layer with, if you're lucky, a caching engine in front of it. So throughout this investigation, we realized that some people, visit one page 37 times and never do anything, so they steal a particular resource. Or users do this thing, like they price an item in their cart, 3 times, refresh this page 5. Some people would edit credit card information 6 times to make sure it was proper. They were somewhat paranoid, maybe I don't know how about that. So we got to know our users a little bit. We realized what they were doing. We gathered some data. We can hopefully model how they access the system. So now we need to know what their systems are doing. So I asked my systems, hey there, tell me about yourself. When we took out the drinks, that's not how I really access systems. So, how we really got to know our systems was we developed like a few basic baselines. We defined like core health metrics basically by response code, response time, and integrity of the data. That was kind of the basis to realize the site was up and it could actually process orders. X-ray black box applications. We were lucky enough to work close with the development team, so we could actually analyze source code and see what things were doing. There's some particular products we couldn't actually do that, so we had to X-ray them, so to speak, via methods like strace. So we coined the term with IGO, what the hell is going on? So, for example, there's a particular application when you choose a certain shipping method, it would utilize 4 more systems 2 times. We didn't realize that, so we could then add that into the formula for the load test. Capture all the Xers, which is extremely vague. Capture all types of production scenarios. Basically, you want to be able to identify what the system's doing during high volumes of traffic, medium volume traffic, and low. For example, we would perform one of these tests. The first test you saw that failed, we'd perform the same test over and over again. We were lucky enough to do that. So when we'd reperform them, we would see a problem like, oh, here's a spike in system X. But we then realized, well, does this spike happen often? So we realized that we need to go back and capture all the different types of production scenarios. So we said, okay, during normal production, this spike happens as well. So it's not really a result of the load test. We need to look at that independently. And you really need to implement a log aggregation or stats analysis tool, stat, because it helped us out tremendously. So again, here's our stack. User requests come in. We can monitor the system for behavior. For example, here's a user that does something that accessed persistent data layer. Here's your initial request. It's submitted to the caching engine, but then since we didn't have that diverse set of data, we'd use the same customer data over and over again. We would just continually hit the caching layer and actually go to, like, if you have a sharded database or some type of ring methodology, you wouldn't actually hit the other 2 nodes in the cluster. So it's kind of important that you really had to diversify that data. We had 1 customer and we'd only test 1/3 or 1/6 of the actual cluster. Again, moving into, you really need to build similar but unique data sets. We were fortunate enough to some of our read-only data, we could actually utilize read-only copies from production and test against that. Other data is like customer data. We would model the quantity of customer data from production systems. We would copy it and obfuscate it and remove things like identifiable information like phone numbers, credit cards, obviously. Street address we did not because we were a logistics company. So discovering all these systems, we found that it actually looks like this. So once we applied that methodology of knowing what the clusters were actually doing, we could say, okay, we're hitting the cluster in a distributed fashion now, similar as to production. So we were able to see what the production traffic looked like. We applied the test with this new data, and the results were similar. Good. So we know what our users are doing. We know what our systems are doing. And this is kind of what I was touching before. Things we didn't know because we couldn't black box the application. Some particular requests had dependent requests to SAD cluster Y, which would slow down the performance by 23%. We didn't realize that certain cases where this happened, so we didn't test for it. Now we included this in the test, and it affected our results dramatically. As well as third-party services. If you have any credit card providers or any type of like API that's depending on the funnel of your process, you need to consider that as well. And you need to notify those third-party customers because we didn't a few times, and we got in trouble. So. This one's an interesting topic, kind of testing outside of the bubble. Once we received insight into what the users were doing, we could real easily identify the conditions of the customer base. For example, at the time, 40% of our users were mobile. So the connection types we were load testing isn't really the same. We were performing high volume tests from super fast data centers, probably like a hop or 2 away from our point. So it wasn't very realistic. So we had the mobile considerations, we had user speed considerations, browser considerations. Like if your customer has 47 tabs open, is it going to process the request as fast as just somebody who has a single tab open, et cetera? Or if you're on your grandma's computer, things like that. There's a really great book by Ilya Grigor called High Performance Browser Networking. I recommend you read it if not. So to simulate these scenarios, we actually implemented delays at the protocol level, and we inserted randomized pausing in the testing. So what happened is the load test we'd initiate connections, we'd have keep alive open, we'd have small pauses in there to actually keep the connection open to simulate the number of, the concurrent load in the system. During one of the tests, this is an interesting topic. We were producing the same number of requests per second, but the infrastructure team said the firewall shows connections per second by 1/3. That was due after lots of research and figuring out what the heck was going on. We realized that was the case because these connections were so long lived from the test initially, they would connect and die. So like the concurrent connection level on all this infrastructure was significantly lower than the production traffic. So after we implemented these pauses and some basic protocol level timeouts, We actually built up those connections. So for example, each virtual server had 1,000 connections per second. During the initial test, it was 422. Now we implemented the pauses, we're close to 900. So we know we're on the right track. So the next topic is test coverage. The first term is load. I guess it's a pretty vague term for this discussion. That's why I kind of elaborate on it more. There's really three pieces. There's load, stress, and resiliency. We performed all three of these. So load is really the process of simulating and applying volume. Think of it as like a comprehensive application of system usage at scale. It does not imply a specific amount of traffic. You can apply a load of 4 users per second. Load doesn't necessarily mean I'm going to flood the system. And one of these load tests you perform should be normal traffic. Try to simulate a normal day, not like a, oh my God, we're going to be rich day. I kind of likened it, I had the realization riding an elevator. It's like, oh, max load of 500 pounds. This is how much it can take. It's not how much you're actually applying in the elevator. The second test coverage point is stress. So stress is a result of load at scale. So this is kind of a formula feeding into each other here. So how much can the system handle as you increase the load? Also, we would like overwhelm or throttle key resources. At the time, we had two. We had a public cloud and we had a private cloud. So this can get kind of tricky with both cases. For the private cloud, we could actually take nodes offline, the cluster, and machines would move around. Public cloud, we didn't have so much visibility into that. So like we have a pool of 20 web servers and we're performing a high volume load tests. How does the service respond if X number of nodes are taken offline? That's an important thing to consider. And again, I'm kind of duplicating this coverage, but like, you have a private cloud, you have end-to-end visibility. So you can get your infrastructure guys in the room, and your networking guys in the room, and you can kind of discover where the problems exist. You have a different set of problems when you're on public cloud because you could be in a different region than the other. Maybe you do a load testing in western region and it doesn't perform as well as the eastern region. You should probably do that to determine if your application is going to perform the same across the board. And the last one is really resiliency. So how recoverable is a system if component X breaks? For example, we thought we had an out-of-band message queue where this thing can go down during a really large amount of traffic, and we can bring it online back at will. And what happens is, well, it can stay offline for a really short period of time, but not during the load test. So that was an interesting discovery as well. What pieces can stay missing when the system is being load tested or there's high volume test? Can this particular box go down? Will the system actually be available to perform or not? What is absolutely necessary for the systems to survive and stay functional? During a real crisis, how would you attempt to mitigate this? You're just going to restart the application. You're going to restart the systems. Can you restart the systems under that amount of load? Say you're performing a high volume load test and you notice there's a problem, you get to restart every box or every service. Can your private cloud handle the restart of all these applications or all these instances? Maybe you can't, and you discover, well, that was your mitigation plan all along. We'll just restart the boxes if we're under heavy load and we'll deal with it that way. But you realize you can't because those resources aren't available because they're being consumed by the other resources during high load. Just some generic items about test coverage. So begin with the basic goal and expand. Trying to start with the simplest thing you can actually work with and kind of build on. You don't want to build a really complex test first. If you have one API endpoint you want to test, get that right first. Do the second API endpoint, third, fourth, etc. Do you want to do browser-based versus service-based testing? Initially we did browser-based testing, or we'd have actually a flow click-through, and we'd get the results back. We'd have to go through 2 million screenshots of when something went wrong. So we actually switched to service-based testing. We use JMeter for that. So and you have to consider too if your assets are hosted in a CDN, if they're locally hosted, those are the things to consider as well. And document each test series. For example, we would have a test and something would break and we wouldn't document it, and we'd have to come back later and say, oh, did this break during test A, B, or C? So it's really important, even if you have somebody in the room that their goal is to take minutes, they can be a part of the test and feel valuable. Another important piece is varying test lengths. We would do 30, 60, 90, 120, because sometimes, not all the time, they would perform the same. Sometimes they would perform drastically different. You discover long-running memory leaks, etc. This is kind of the circle of testing: test, review, and adjust. Last topic: listing beneficiaries. Who are you really testing for? Are you testing just if you're an SRE team, if you're a DevOps team? Are you testing for yourself, or are you testing as the team as a whole? So you're really we involved all our stakeholders. At first we didn't. We just did our test, and obviously it failed. Then we involved everyone. We had devs in the room. We had infrastructure team, and operations, and more. So once we developed a good strategy, operations team didn't really have one. So we kind of developed the framework, we shared it with them, and they applied it. So you're kind of working on the same page. Before, their framework was, oh, there's a spike. It was a really vague term. We can never really identify when a problem was. So it's kind of develop a similar strategy and spread it across your organization. And share your results with your peers and review them. Because Maybe something they're doing is incorrect, and they actually identified something we were doing as incorrect, so it was beneficial. So really, this brought us on the road to improvement. We really got two key things out of this. We fixed problems that were introduced at mass, and we used this formula to extrapolate to not follow the false preparedness model. So we found out what the hell is going on in the systems, we generated accurate user load, we created a new test, and the same exact thing happened in production as it happened in the test. Maybe you expected this to look different, but that's what we wanted, because now we could actually isolate when the problem occurred and when it failed. So here's kind of like a replay scenario. We had one of these spikes, one of many spikes that caused the production outage, was identified as the very first bullet point of DNS latency. Before we did this test, first round, someone said, you're making too many requests, you need to cache them more, that's the problem, fix it. We tried to argue against it, and it said, nope, that's the problem, fix it. So we did. Then the spike happened again. So we went to the second bullet point, like, oh, maybe this is it. And we did the test again. They said, nope, production outage. Oh, crap. So next time, we went to the next bullet point. So what ended up being, this guy said, oh, fix your DNS, bro, we did it. Increase your timeouts, we did it. More threads, we did that. 50 boxes. All during this time, we were actually proving ourselves right, because initially it was, this is the first problem, and you need to fix this, and everything is good. Our stuff is solid, man. And since we had this methodology to continually test over and over again consistently, we were able to identify these problems down the line and actually fix them. Versus, no, this is it. Just fix it and we're done and we're out of here. That's the original mentality. We got shifted to, well, we can go down the chain and fix problems as they occur. So it was a good thing. The initial test, not so much, but it worked out pretty well. And we went from a false preparedness model to a data-driven preparedness model. So we could take out X number of hosts during the test, and you'd actually say, okay, well, I don't need 20, I need 18 or 17. So it can benefit you if you reserve instances on Amazon, you purchase them or not, or if you have a private cloud, you already spent the money anyway, so who cares? So miscellaneous advice is really maintain focus on the load testing plan. It's easy to get put off track, and one small thing comes up when you focus on that. Attempt to pinpoint the time of failure, as I mentioned before. Documenting these times of failure is extremely important. Know your systems and being confident what they're doing. If you're not confident and you're not sure what they're actually doing in the back end, then how can you adequately test them and figure out what's going on? Use consistent tooling. For this project, we used JMeter, and we utilized a cloud product called BlazeMeter. So we really developed all the tests in-house. They're pretty versatile, and we just upload the templates to a third-party product. So that was cool. You don't have to use that tool whatever you want. Just make sure it's versatile and can be used across the board. Test as often as you can if you can afford it. Initially, we had the blank checkbook for the first failed tests, but after that, we wised up and we could realize we could create some of this stuff in-house using JMeter. So that's how we were able to be creative and choose large load tests from paid providers quarterly. Clean up when complete. This was kind of a bullet point I thought of the other day. We actually did a load test against an inactive production environment, didn't clean it up, and we switched to it, and we had the same problem as we did before. Lost customers, and this should never end. You should never stop load testing. So every new feature, every new implementation, every new firewall replacement, you should perform additional tests, because each of these is a new piece introduced that could potentially cause another outage, and you can't identify it. So just to review again, the 5-step program: getting to know your users, getting to know your systems, testing outside of the bubble, establishing test coverage, enlisting all beneficiaries and stakeholders. So really, this is kind of like a framework, not just to handle the rush, but you can handle anything. A little segue there. Any questions? Questions? Concerns? It's a constantly evolving process, unfortunately. It's not like, oh, we have this sweet template now we can test. We find holes in it all the time.
So this has mostly been about discovering the broader scope of everything you can test.
Mm-hmm.
Have you looked at, once you figure that part out, splitting the load testing up so that you can do kind of small deployments of small parts of code without having to redo the entire test? Is that something you're
So you're thinking more like componentized testing? Like,
load?
you know, we tried that at first, then we had some brief discussions about it. We realized that we were going to do it like a holistic test every time, because we actually never really proved it, so it's actually a good discussion point. You could actually test pieces, but when they're functioning together in an entire ecosystem, they might not perform the same way. So we kind of always assumed that we're testing under a production customer scenario, so we'd have everything involved, which, don't get me wrong, it increases the amount of workload and time and resources by a huge factor, but you're then confident in your tests. You don't have to have those mini meetings like we had. So I guess you can spend your time working on the tests, you can spend your time in meetings debating about the test afterwards if it fails. We kind of shifted towards err on the side of caution.
So presumably you have a third-party vendor for payment gateways, things of that nature.
Pardon? I couldn't hear the question.
You have a third-party vendor for transactions for actual payment processing?
Yeah.
Okay, so how do you handle those scenarios where you're trying to load test your system without inundating the others?
So we were lucky enough to have basically they spin up a development environment on demand that we could point to. And at some point we'd realize that we had to trust that customer to assume the risk of load testing. So we made sure we had a system that was almost basically a dummy processing system that could handle as many transactions as possible. But past that point, it was out of our control. So we really kind of transferred the risk to them. We said, this is how many transactions we typically process during a large event or like a typical Friday or whatever. So we kind of said, well, you need to be able to handle this, because there's a few times we'd apply a lot of load and they would go down. But there's nothing we could really do about it as a customer. I mean, we were one of tens of thousands, so we couldn't really force them to do anything. So we kind of just transferred the risk. And it was a win for both, because then they could improve some things too on their system, and it's in their best interest to keep the system up because they receive money too.
Is it easier? Again, I didn't get the impression from your slides that it's a large distributed sort of system that you run. It's largely you've got a cache layer, a web layer, a database layer. Are you able to break that out, as you touched on, with components, so you can actually isolate where these failures occur and whether you're going to experience any kind of not background? You follow what I'm saying?
Yeah, and we did that to some degree. For example, I don't know how much I want to divulge here, but there were some data pieces on here that weren't shown, and they were very extremely slow connections. So we would sometimes simulate those. We built a mock processing system for that would just insert random time events to simulate that. So some degree of things.
I think Brian should do an open space on this topic.
Yeah,
who
sorry,
votes for that?
I'm yapping and
No, you're good.
yapping and stuff.
Give it up for Brian. Good job.
Thanks.